Hello there, it's devlog time again. And today we are finally going to finish the minimal viable products that we specified in the first episode of this series. So yes, when this video is over, we have our actual first ever gameplay loop. And even if it is very bare bones, this is always a satisfying moment for every game dev, so I'm very excited. So in the first video, I wanted the following key things for the MVP. And yes, I actually went back to watch my first video to screenshot those key points because I deleted the presentation for some reason. And I will let that be a lesson for myself to never re-watch my old content because I almost died of cringe over the terrible audio and non-existent editing. But anyway, as you can see, we already finished the first 3 bullet points and the pop-up screen. And what we still need is the next day button, the stamina mechanic, and the resources. We will start with the button to progress time, so let's add a quick texture button for it. Let's put it in the bottom right corner and add it as an export to the Spring Manager script. And now we can start coding the button logic, so let's begin by connecting the button signal to a new function on progress button click. So as usual, in the ready function, we add the signal listener, progress button dot button down dot connect, and then the function name. Let's clean up the debug trash here real quick and put it in a separate function. Like this. And now it's nice and clean. So for the sake of having a nice and clean structure, I don't want the main game logic in the Spring Manager root node, and instead I will add a new node that I will call GameState to hold the script that will manage the actual game progress. And in that GameState script, the first thing we are going to add is a function that will manage the passing of in-game time. So let's create a progress time function. The Spring Manager script will potentially need a reference to the GameState node, so let's add this real quick. And now we can just call the progress time function from the button event listener. So the progress time function will essentially be where all game logic comes together. So this needs proper planning. First off, we need 2 different variables to keep track of the in-game time. The first is obviously the day counter, and the second one is the phase counter. I think the day counter should be self-explanatory. But the phase counter, we need this to increment whenever a player wants to resolve the current batch of customers. Let's add another variable that we call phase max. And for the sake of getting a first gameplay loop going in the progress time function, I set it to 3. So we will randomly create 3 batches of customers to resolve. On second thought, these should be globals because we might want to access them from anywhere in the game. So let's put them in the globals script. And we only want to set phase max when the current phase is 0, because otherwise we would have an infinite loop. Now that we got this, we can resolve all active customers in this phase. So we run through the array of active customers and resolve each instance. And luckily, we have already set up the resolve function to properly clean up the UI, the arrays, and everything, so we don't need to take care of anything else in the process. This is very convenient. In the next step, we need to generate a number of new customers for the progressed phase. So we just create a counted loop and call the customer add function multiple times. Easy. And now for the final step, we increment the phase count by 1. And in case we have hit the max already, we increment the day count and reset the phase count back to 0. Don't mind me, just renaming things here because I'm stupid. Alright then, it's time for a little test. So let's add a quick debug and press play. And if I click through the customers, and I can see the counter increments properly, which is what we wanted. Okay, so this is where it gets a bit tricky. The problem is that we obviously want to show pop-up windows whenever a list of customers is resolved, but those require user input, so we can't process them all at once. Now, I could technically just code a simple resolve queue for that, but I want to create something a bit more powerful because we will have lots of queues like this in the future. After all, this game will have visual novel style events at some point, so it's good to plan ahead. So what I'm gonna do is create an actual event queue system. So we will have a new game event class that will have objects that we can put on a stack to be resolved one by one through the user. And once that whole queue is resolved by the user, we give control back to the progress time function to continue with the game progress. So let's start by creating the game event class. As usual, we make the branch a scene and give it a class name. And we don't need that stuff here. And then we need to add the scene path to the globals as always. And last but not least, we create our usual add function and attach the instantiated node to the scene tree. In this case, I want it to be a child of GameState so that everything is organized. The properties of our game event object will for now just hold a callable variable. This is essentially the function to be executed when the game event is triggered. And of course, events usually also need some kind of data to know what to display and show, etc. So I add a dynamic type variable here that I call data, so that game events can essentially hold any array or dictionary to access in the triggered function. And now, to keep everything clean, we just want a simple function that calls the callable and passes the data over. Next, we also need a list of all the events existing, so let's add a static array for this. And now we just need to add the newly created event to the end of the stack. But I want to have the option to push to the front too, so I will add this as an optional boolean. So let's add the boolean here in the function parameter and then create the if structure. And now we can add another static function that will just play the next event in the queue. Now, obviously, we need to destroy the used up events, so the node is in desperate need for some good old-fashioned freedom here. We should definitely add a failsafe here. Oh, almost forgot, we need a fallback function because we want to give control back to some other function after the queue is finished. And now our failsafe even makes more sense because in the else branch, I can just trigger the fallback. And I just noticed that I brutally violated the Godot naming convention, so let's fix that. Also, just to avoid issues with events that don't need data, let's make the data package optional here. Alright, the moment of truth has come. We go back to our GameState script and update the loop here to use our new event system. And we also want to trigger the first event. And if we test this now, I expect the following to happen. It adds 3 new customers per click on the progress button. Why? Because the first customer is resolved through the first triggered event in the queue, and then the next doesn't play because we haven't added the logic from the user input yet that triggers the next event in the queue. And this is exactly what happens. The first customer's gone, and 4 new got added at the bottom, so 3 in total. Okay, I know I said I wanted to make a minimum viable product in this video, and I did. But after editing and cutting everything, I noticed that I had way over 20 minutes of video, so I decided to split this up into 2 parts. And this is the first part, and the second part will be released early next week. So stay a bit more patient until then. And yeah, I hope you will tune in again to the second part of this. Enjoy and have a nice evening. Bye-bye.